For our project, we chose invasive species as our problem. By definition, an invasive species is any organism that is brought to a land in which it is not native to. These species become incredibly threatening to the environments that they are added to, specifically when it comes to endangered species. Approximately 42% of all endangered species are a result of invasive ones. Invasive species lack predators in their adopted environment, making it easy for them to grow unchecked and take over an ecosystem. Plants can be particularly difficult to control or eradicate because they normally grow faster than animals do and can be harder to distinguish in the wild. Invasive species are detrimental to the environment because they decrease native biodiversity by stealing and outcompeting natives for resources to survive. This negatively skews the food chain, which causes some species to die off while the invasive ones thrive. Examples of this are the Burmese python, kudzu, Norway maple, and reed canary grass.
We examined the existing solutions, and the first one we looked at is biological control. Biological control, often shortened to biocontrol, is the process of introducing natural predators of invasive species into the same environment to control its population. Practically all organisms have predators that feed on them in their native environments. In an ecosystem where a foreign species is running amok, a predator native to the same environment as the foreign species will be introduced in the same ecosystem to control it. A weakness of this method is the time requirement. The introduction of new species is tightly regulated in countries and takes a considerable amount of time to carry out. Another weakness is the chance of non-target side effects when other species besides the intended one suffer as a result of a new predator. Bias to this method comes from it being successful in the past, as well as it being the most documented in a field where there is not always complete data. Also, biological control does not result in eradication, leaving the possibility for repeat invasion.
Another solution we researched was chemical control, the use of pesticides to kill vegetation. A weakness is that use of pesticides can also lead to pollution runoff. The more that is used, the greater the likelihood of pollution. This can lead to eutrophication, a massive increase of nutrients. An example is using herbicides to kill and remove autumn olive plants form a local field or woods.
The third existing solution we researched was manual control. Manual control techniques include activities such as hand pulling, digging, flooding, mulching, burning, and manual destruction of or removal of nests, egg masses, or other life stages. A weakness of this is labor and cost. An example includes flooding an area to drown East Asian Juro spiders that have recently been found as invasives in Georgia.
The final pre-existing solution is prescribed fire. Prescribed fires are used to reduce invasive and woody plant density and competition, stimulate the growth of native plants, return nutrients to the soil, promote germination of dormant seeds, and enhance wildlife habitat. These burns are called controlled or prescribed because they are done only under specific weather and fuel-related conditions that ensure an effective burn and the safety of the burn crew and surrounding area. Some weaknesses of this problem are prescribed burning damages the whole environment since native species may also be killed. The risk can cause displacement of animals and a decrease in the native vegetation population. An example of this is lighting a crop field on fire in a local farm to kill invasive coggin grass. The problem with this is the crops will also die as well as displacing any natives living in that field. This will hinder food supply despite it ridding the field of the invasive species.
The solution we came up with is harvesting invasive plants as an energy source. Plants are some of the most difficult invasive organisms to remove. They need to be disposed of in a way that will prevent them from spreading. Utilizing the plant refuse waste is a way that can benefit us as an energy source while also decreasing the amount of waste present. The direct beneficiaries are the ecosystem that are having the invasive removed and humans for having the extra energy provided. We can see this replacing coal in coal-powered systems. A study conducted at Lake Superior State University examined the BTU yield of unmanaged reed canary grass and whether it would be energy efficient to harvest and process it into pellets, and then burn it in a multi-use stove. A 3-acre patch of reed canary grass could provide in pellets the BTU equivalent of 800 gallons of propane, with 30 32 times more energy return than the energy required to harvest and pelletize it. Most rural properties in our area have some strands of reed canary grass.
Another strength of the solution is that businesses can be started to harvest, manufacture, process, and sell these pellets and thus energy source. This would create a new industry and will be very appealing to farmers to give their support. These farmers would make a profit off of removing the invasive species that are destroying their crops, which is a definite strength of the solution. As for the new energy source, the plants grow so quickly and in large populations that despite farming, there will always be a large supply. This would make it a great replacement for propane, as propane is non-renewable and therefore will become more expensive as it is used over time. Since the grass is heavily concentrated, its price will never increase as much as propane, which once again is a strength due to its cost efficiency.